Hi, and welcome back to the Crocker Science Center Laboratory Informational Video Series. Today we're going to go over a brief introduction of how to use Excel to create graphs. There's no way we can cover every possible function or tool found in Excel, nor will we try to. The intent of this video is solely to help you get comfortable with basic Excel use, especially if you haven't used it before. We'll take 2 or 3 sample data sets and go through the process of creating 2 different types of graphs from that data. As a side note, if you do not currently have Excel on your computer, university students can download the whole Microsoft Office suite for free because of an agreement between Microsoft and the university. To find that, the link to download it, just go to utah.edu and search for software licensing. Okay, first let's take a look at a set of sample data representing a temperature versus time examination of a solution, shown here. On the left column is our time data, and on the right column you can see the temperature data. Now, to get data into Excel, you can either copy and paste it from a different source, like a text file for instance, or you can enter it in by hand. Either way, once your data is in the spreadsheet like we see here, you want to select the data that will be included in your graph. An easy way to do this, especially if you have a large data set, is to select the column letters. This will select all data in those columns without you having to scroll down to the bottom of your data set. So for instance, see this little down arrow here? I'm putting it in the C heading of the column, and then that allows me to select the whole column. And if I remain holding the button, mouse button down and slide over, it will select the next column over as well. Now you can also select data simply by dragging and selecting columns like that, but if you have thousands of data points, that can be kind of hard to do, and this makes it very simple. Okay, there are multiple ways to make a graph. Here, for this particular example, I'll just go up here to the Charts tab and select the type of chart that best fits how I want to represent my data. In this case, I'll choose a smooth line scatter plot, which is going to plot the individual data points and then connect those with a smooth line. So I go under Scatter, Smooth Line Scatter. Let's enlarge in this plot that was created. Okay, you can see this chart that's been created. Excel has included some labeling information based on the column titles from my original data up here. However, we're going to want to modify some of this labeling. For instance, the current title doesn't give a good description of the data represented in the graph. So to change it, let's click on the title to select it, and then click one more time to be able to edit the text. So now we can edit it very much in the same way that you would with a Word document. We want our title to be succinct, but still be an accurate description of the data represented. Someone looking at this graph should be able to quickly and easily tell what information they will be examining in the graph simply by looking at the title. For instance, we might name this temperature versus time of solution X, where X is whatever solution you're working with. And let's go even more specific and name this trial 1. Let's suppose this was for a particular trial of an experiment where multiple trials were performed. Here, of course, you'd substitute the name of the solution in for the X. The X is just a placeholder here. Since we are only displaying one set of data on this particular plot, we can delete the legend. If we were displaying multiple sets of data on the same plot, then we would want to include the legend to delineate what each of those sets of data were. But for now, let's just delete the legend. Click on it, delete it. Now let's add axis titles. So if you go to the Chart Layout tab while the chart is selected, if it's not selected, then you're not going to have that. If you select the chart, go to the Chart Layout tab, we can select the Axis Titles option, and this allows us to edit both the horizontal and vertical axis titles. Now, as we're doing this, you want to make sure that for each of the axis titles, you include both a name and a unit, if applicable. So let's go ahead and do a horizontal title, so a title below the axis. And you can just start typing, so we might name this, we want to give it an accurate description. This is our time, So that's our name, and we also want to include the units. So this is in seconds, as we see from our data. Then I also want to do a vertical axis title. I usually do a rotated title. That puts the title kind of sideways and reads bottom to top, basically. And so let's say we call this, this is our temperature axis, so temperature, and this is in degrees Celsius. You could put the degree symbol rather than writing out degrees Celsius. You put degrees C, right? But I'll just write that out. And so then I've got two axis titles with both a name and a unit in both cases. So always include a unit if it's applicable along with the name of the axis title. Let's see, there are many other options for formatting your graph. You can access some of these by selecting your graph. For instance, let's select it and then going up here to the Format tab. And for instance, let's say that I wanted to change the color of the line representing my data. I could go to, let's see, the series, which is the data, and then change the line color to black, and that changes it. And there's a lot of different things you can do with background colors and different fonts for your text and all of this. So we're not going to go through all those. I'll leave you to play around with a lot of those options. One more that I will point out here, though, is we may want to, for instance, reformat or resize our axis so that the graph is more appropriately positioned. In other words, we might not want the graph to go all the way to 0 degrees C. Maybe we want it to stop at 20. So if I right-click on the axis and say Format the Axis, I can go over here to Scale and set my minimum value to, let's say, 20. The maximum is currently set to 60, and I can change the units. There's things you can do there, but you can see that repositions or rescales this particular plot. So that can be a really useful thing, and you can do that with the x-axis as well. All right, let's look at another sample data set. This data comes from examining the absorbance of different solutions, well actually different concentrations of the same solution using a spectrometer and correlating that with those solution concentrations. The absorbance values are given on the left column and the concentration data is given in the right column. Absorbance is not usually presented with units, so we won't include them here in our graph. And just like in the last graph, we'll select the data and choose a chart type. So let's select the data. And this time I want to present each data point as just a single point on the graph. So I'm just going to choose a regular scatter plot. So go up to Charts, Scatter, and just a marked scatter. You can see that each data point has its own little point on the graph, right? Again, we only have one set of data we're presenting here, so let's go ahead and get rid of our legend. Since the relationship between absorbance and concentration is defined by the Beer-Lambert law, something you'll talk about if you ever have a general chemistry course, this graph of absorbance versus concentration, or biology course for that instance, this graph of absorbance versus concentration is called a Beer-Lambert plot. Therefore, when we rename this, let's call it the Beer-Lambert plot, let's say for copper 2 sulfate solutions. Okay? All right, or whatever solution you might be looking at. And we're just going to assume that this was copper 2 sulfate, for instance. Let's put in some axis titles. Remember, no units for absorbance in this particular case, but we're still going to put in no units so our TA or instructor knows that we didn't just forget. And before I do that, before I actually go in and label the axes, you might have noticed an issue with this, namely that I really actually wanted absorbance on my y-axis and my concentration to be on my x-axis. Notice the highest concentration goes to 0.5, but I'm way out here at like 1.5. Well, the reason is because my absorbance got plotted, these absorbance values are on my x-axis, and the concentration's on my y-axis. So if I want to flip-flop that, how do I go about doing that? Well, you can right-click and say Select Data. Then you choose the data set. So we only have one series of data on this particular plot, so that makes it easy. And we go to the X values and click this little graphical chart symbol here. And then that puts us back on our spreadsheet. Right now you can see that our X-axis values are defined as the absorbance values in our list, but I wanted them to be concentration. So I'm going to just scroll and select my concentration values. Come back over here and hit this button to return to the Select Data Source window. And then I'm going to do the same thing for the Y values, changing those to my absorbance units. Now that those have been properly changed, I click OK, and you can see that my absorbance is now on my Y-axis, my concentration is on my X, which is what I originally wanted. Okay, so let's put in some axis labels. So we go to our chart layout, axis titles, horizontal. So that again, we said our X-axis is concentration in units of molarity, and our Y-axis, so we're going to do a rotated title, is going to be absorbance. And again, I'm going to put in no units to make it clear to my TA or instructor that there's a reason I'm not putting any units, not just because I don't feel like doing it or I forgot. Okay. All right. So now for something new with this plot, because up to this point on this particular set of data, we've just, again, taken the data and graphed it, largely been the same as what we looked at with the first data set. But sometimes you'll want to see how a data set fits into an expected mathematical relationship. In this case, we expect the relationship between absorbance and concentration to be linear. To see how closely our data fits this linear relationship, we're going to perform what's called a linear regression analysis. To do this, you can start by right-clicking on one of the data points, and this is going to bring up some options for us. We want to use the Add Trend Line, and since we expect a linear relationship in this case, we'll choose the linear regression type. This is what is chosen by default. Then if we click on the options part of this, we can also choose to display the equation on the chart for that particular line that best fits our data, as well as the R-squared value. So we'll include both of those and click OK. And now you see that the equation and R-squared information is displayed, and we can move that around to different parts of the chart simply by clicking and dragging on that. The equation shown can be useful for making calculations or predictions based on your gathered data. And the R-squared value tells you how closely your data matches the expected linear relationship. The closer to 1 the value is, the more closely your data approximates a linear relationship. Okay, let's go through one more exercise. This time, going over how to perform calculations on large volumes of data before graphing. We'll start by looking at temperature versus time data again. Here, the temperature, and let's get rid of these because those aren't supposed to be there. But let's clear all. There we go. Okay, so we're starting by looking at temperature and time data again. And the temperatures are presented in degrees Celsius. But what if we wanted to graph the temperature in Kelvin? To go from the Celsius scale to the Kelvin scale means adding 273.15 to whatever the temperature is in degrees Celsius. Now you could get out your calculator and do that for each temperature, recording the new temperature in the new column as you go through and do those calculations. And maybe that's not too bad if you only have a few data points. But what if you have thousands of data points? That'd be a horrible waste of time and completely unnecessary, because Excel makes this kind of calculation for large amounts of data very easy to do. First, to show you how we're going to do this, we're going to click in the first cell in the Kelvin column. And we're going to start by typing in the equals sign there. This tells the program that the value of that cell will be dependent upon a calculation. Since we want to add 273.15 to the temperature in degrees C, I'm going to click on the cell containing the temperature in degrees Celsius that I want to add 273.15 to. So I'm going to click the 54 degrees Celsius. Notice it references that cell, which is B2. And to that, I'm going to type in plus 273.15. All right, when I press enter, the calculation is done for me. This calculation is taking the cell value to its immediate left, the 54, and adding 273.15 to it. Now I can simply take that cell, I can select that calculation cell and drag the bottom right hand corner, see this little knob right here, grab that and pull that down to the other cells where I want the calculation done. The calculation is copied over for each cell, but updates to reference the cell immediately to the left. In this way, I have now completed the calculation for 30 data points, and I have a new column of data to graph. So here, this cell referenced B2. This cell, you can see, is referencing B3, the 42. The next one will reference B4. The next one reference B5. So because the first one referenced the cell left of it, the next one will do the same, and on as you pull that calculation down. So it allows you to do calculations over really large amounts of data very, very quickly. Okay, but if I want to graph the time and temperature data, but temperature in Kelvin, notice that the two columns of data are not right next to each other. So I can't just select all three and create a chart, because I don't want to graph the temperature in degrees Celsius. I want to graph Kelvin and time. So how do I do that? Well, I can click in a blank space in my sheet, right click, and then do insert, or you can just go up to your charts function like we have been. And let's say I want to do a smooth line scatter. I can choose smooth line scatter, and it'll put in a blank chart for me. Let's enlarge that just a little bit. Then I can right click in the blank chart and say select data, and this should look familiar to you. Now we don't have any data here to start, any data series, so I'm going to add a series. By default called series 1. You can change that if you want, I believe. Let's see. Yeah, you can change the name right here. But I don't care about the naming of that series particular right now because I'm not going to have a legend. And so I can then choose my X and Y values, much in the way I did in my last example. So I can click on the X little chart symbol, go over here to my time and select my time values as my X values. And then do the same thing for the Y, but I'm going to select my temperatures in Kelvin. When I click OK, you can see the chart is created. Let's get rid of the legend. Notice it was called just Series 1 because I didn't rename that. And so now I have a graph of temperature in Kelvin versus time. And if I click on that graph, it shows you where that data is coming from. You can see it's pulling from the two columns that are not right next to each other, but the ones I selected. So of course I would then go on to include an appropriate title and access titles with units, but since you know how to do that now, we'll skip that here. Now there are many other things that Excel can do, but hopefully this brief introduction helps you to feel comfortable enough to start using the software to create plots and analyze data. As always, if you have any questions, ask your instructor or your TA.